So continuing to practice this, from the outside in, we want to do the power, the opposite power here. So if we have root 5, we're going to do power 5. So we have root 5. This becomes 2 to the power 5 times our factor of 2 that we had in there to start. Okay, so this 2 to the power 5 on the inside is same as 2 on the outside. So we end up with 2 to the power 6, or 2 to the power 5 times 2. 2 to the power 5 is 32 times 2, and that's really the same as 2 to the power 6, okay, or the fifth root of 64. So again, we want to, if you just keep track of these factors, 2 on the outside, 2 to the power 5 on the inside, which becomes 32. So again, on the outside, this is equal to 3. On the inside, we have to do the opposite, because the 3 really is representing this 3 to the power 3 on the inside, because cube and cube root undo each other, so we'd end up with 3 times our factor of 5. Okay, and again, understand that this multiplication is implied here. So I end up with 27 times 5. Okay, and then this works out to be, looks like 135 cube root. Okay, and this factor of 27 is coming from that original factor of 3 on the outside. So index of 4, we do the power 4 to bring it to the inside. So there it is, that power of 4 allows the outside factor of 3 to come to the inside of the root. 3 to the power 4 is 3 times 3, which is 9, times 3, which is 27, times 3 is 81, times 2. So we end up with the fourth root of 162. Okay, so we want to find the square. In this case, we're just going to focus on square roots. We want to find the square root functions. To do square root functions, we want to try to find the perfect square factors. Okay, so the index is 2, so we're looking for perfect square factors. So that 72 can be broken up into the perfect square factor of 36 times 2. We can square root the 36 and bring it to the outside, and it becomes 6 on the outside. So 6 squared on the inside, 6 on the outside. So applying that process then, if we have squareds, we want to look for powers of 2. Okay, now we can take out 100, which is a power of 2. We can also take out 10,000, which is a power of 2 as well. So I'm going to break this down. Okay, so 10,000. Okay, so 2 zeros is 100. I can add 2 more zeros to get a perfect square. And if I divide that out, I'm going to be left with 20. And I recognize that 20 has a perfect square factor as well. So there's my 10,000. You can take that out as 100 squared if you like. Okay, and I'm going to do this in steps. I have a factor of 4. I have a factor of 5. These two factors I'm going to color here, 10,000 and 4. These represent perfect square factors, so they need to come out of the square root. We can actually square root 10,000, we get 100. If I square root 4, I get 2. And then I'm left with the 5 in the square root. And that's our lowest term radical, is when we take out all the perfect factors, perfect square factors, and express them on the outside. Now we shouldn't leave it like that. Really, this should be 200 square root 5 is our final answer. And you can check this on our calculator. We can square root 200,000, and then we can try 200,000 times square root 5, and those two numbers will be exactly the same. All right, so here we have a power of 4, so I need powers of 4. Well, I know if I have 4 zeros here, that means I have a perfect power of 10. Perfect power of 4 with base 10. So I'm going to rewrite this as 10,000 times 5. The 10,000 can be rewritten as 10 to the power 4 times 5. These we know undo each other. Again, I just want to highlight these. So we have 10,000, that's 10,000. 10 to the power 4, the fourth root just becomes 10. So power 4 on 10 to the power 4 on the inside, 10 on the outside. And then inside that fourth root, we're left with just the 5. And it's important that we recognize the root. We're not always dealing with square roots. We often deal with square roots, but not always dealing with square roots. So here we're dealing with cube roots. So what I'm going to do is count groups of 3 zeros. So that's 1,000, 1,000,000. Those groups of zeros, I know I can rewrite in terms of powers of 3. So I'm going to have 10 times 1 with 1, 2, 3, 4, 5, 6 zeros. Okay, so 10 times a million is 10 million. Okay, so that 10 million can be expressed into groups of 3, or powers of 3. So that's 10. That's going to be 10 to the power of 6. Okay, so I end up with there's our 10 million perfect cube factor. And so on the outside, that's going to be, well, the cube root of 10 to the power 3 is 10, and then another 10 to the power 3 is another 10. So on the outside, it comes out as 10 squared. On the inside, I'm just left with that extra 10. Okay, so there's my 10 to the power 6 cube rooted on the outside. It's equal to 100. And so I'll rewrite that as 100 cube root 10. Here I have, it's kind of hard to see, but I'm going to try to pull out some factors here. I recognize that 3 to the power 10, 5 to the power 3 is going to give us a 125. And then I'm going to end up with 10,000, which I'm going to break into 1,000, which I know is a power of 3, times that extra 10. Okay, so you may do this slightly differently, but basically we're trying to find factors that are perfect cubes. So there's a perfect cube out of 10,000, out of 100, and it looks like 1,250,000. I'm going to pull out 125 factor. That's a power of 3. So I'm going to rewrite this as 5 to the power 3. I'm going to end up with 10 to the power 3. And times that extra 10. Okay, these undo each other, so I'm left with 5 on the outside. Okay, and again, make sure that you're keeping track of your factors, and it's good to use brackets if you're losing track of these things. So these are all factors, so it's all times, so I'm just keeping in brackets just to make sure that I can see it's all multiplication. And there it is. Okay, I'm just going to highlight my 125 here becomes 5 on the outside. And then I have my 1,000 shows up here and ends up 10 on the outside. So we end up with 50 cube root of 10.